Hello, I am Monsieur. This example in Panda3D is about basketballs, whereas the last example I made dealt with generating something that travels in an arc. This example also deals with things that travel in an arc, but they've changed the code to be more useful in a practical sense. This program kind of simulates what throwing a basketball is like. So let's show what happens in this program. I've set up this scene where a character model I've made, along with these other assets I've downloaded online, can move around the scene and has the ability to throw a basketball. And the point of this program in particular is that the ball can collide with a hoop, and there's a score counter on the right of this program here. So every time the ball goes through the hoop, you will get a point. So I will rotate this to face the hoop. And by pressing Control, I can launch a basketball a certain distance. And you can see, since the counter went up on the side, the basketball collided with this collision sphere here. Ooh, I'm a little sick today. This model here is important to the program because the basketball takes the idea is to get the relative direction of the idea is to get the direction the model is facing, and then while the basketball is traveling, incorporate that direction into its arc. So whenever the basketball is thrown, it will be traveling in a direction relative to this player model. So rotating it will have the model throw the basketball in front of it. As that happened. And the other kind of feature of this program is that holding down the fire button, which in this case is Control, will increase the power at which the ball is thrown. So looking at the terminal over here, you can see that when I hold down the power button, the power will increase to 10. And then if I keep holding it down, it will go back and forth from 10 and 1. So since this program is a little more complicated than the previous ones I've made, I made this kind of graphic explanation of how everything works. The text that's under the green text is the class, and the text that's under the blue text is the class method. The other things here are just methods in the program. So take a look at this if you want to get some background information without reading too much into the program. But first, to start off in launching the thing that the player has, I have this Panda3D task that I have being called every frame. Actually, every 0.01 seconds. So I wanted to set up the variables for what I want the basketball to be launched with. So to do that, before I launch the basketball, I look for these inputs that the function can use. And like I was showing in the program, when the control button is held down, the power can be increased and decreased between 10 and 0. The way I did this is kind of important. Since Panda can accept key presses through events using the this line of code to detect what button is held down isn't what seems to be the recommended way to do it. However, I wanted to do it this way so I could, I believe, be able to time when things happen. Since I don't think you're able to time when events are detected. So first the power starts increasing for what you're going to apply to the ball. When you hold down control, while it's held down, this second variable is important. After it's held down, it if this variable isn't set and I wanted to launch the ball with the power of this variable, I wouldn't be able to detect when a key is released using the method that I'm using, because having a button not be pressed isn't the same thing as having it being released. So first it's pressed, and then whenever it's released, it could be in this function or whenever the next time it's called. You have this setup code, it's called, and then before the actual function to throw the ball is used, this line of code is important. This is the line of code that says I want to get the direction that's in front of the player model. Depending on what direction you want to be in front of something, that could be left or right of the model depending on how you export it from your 3D model, or you could have it just be straight in front of it, which in the program I've set up is in the direction of 1 on the y-axis, meaning completely forward on the y-axis, and not in any direction on the x or the z-axis. The x direction being the other horizontal direction, and the z-axis being the height direction in Panda3D. Something else that I found while I was working with this that I kind of made a mistake with was be aware that if you press Control in this program multiple times while the ball is still in the air, it will cause it to kind of glitch out and calculate different positions at the same time, because I'm not running any kind of restrictions to say I only want one method to be running. So that's something to be aware of whenever you're making mechanics. To whenever you start something, not have multiple of the same mechanic running at the same time. But it's up to you how you want to do that. The problem I was having was in this function, which is the function that's called after I set up all the variables. I was just returning to add the task to the task manager again when the function is, when it's executed everything that's in the function. But again, the problem is, since there's nothing in this program tracking how many method instances there are at the same time, the same ball in this program could be set by a lot of functions running at once. So it's a interesting kind of thing to be aware of. So after I set all these methods to set the strength and a variable that helps with setting the height, I'll launch the ball using this function, which is the actual math used to calculate where I want the ball to be. I changed the code on how many times or what the conditions are for this to be running since the last program I made. Even now, this kind of setup is just made to experiment with how you can kind of figure out where you want something to be placed by using math to kind of figure out the horizontal position and the vertical position. But Panda3D itself has a projectile interval in its manual that can calculate a position in an arc for you. So that is useful, but I believe it's more helpful to have the flexibility of what's actually happening yourself in whatever program you make. Makes it easier for me, at least, to understand. So the concept behind this is the model, or the ball, is going to be moved like 100 times in its arc according to whichever way is relatively forward of the model that's being thrown from. Panda3D kind of makes it easy to do this with this line of code, since this line of code is moving something relative to a model or a node path. I'm moving the basketball relative to itself, and the direction I'm moving it in is this variable, which I set up in the setup function before. And it's not a actual just concrete number, but a number that's something in 3D space that's forward of whatever model the player is. So what this does is move something in the direction that's determined to be forward from the player, but it does it in a way that's relative to this model. So it can continue to travel in the same direction, but still be traveling from whatever rotation the player model has. And then this is also a vector3 variable, meaning that it has an x, y, and z coordinate. So that's why it's able to kind of determine whichever direction is forward, regardless of which way you're rotating. And this can be multiplied by this number, which is the strength of it. This is the strength at which the ball will be moving. The higher the strength here, the farther the ball will travel, and the faster it will travel. And for the z coordinate in this, I believe I'm using the ax squared plus bx plus c equation, which is a way to find the height of something on a graph. But I'm using it in 3D space here. And the second line here is this is necessary because you want the ball to be thrown from the player, so you need to have an offset where the ball starts at the same height the player's at. Otherwise, the z coordinate would just be wherever it would be normally on this arced graph. So in some situation it would just start at 0. And if you have a player model that's not at a height of 0, it would just be launching a ball from like 50 meters under it, and that wouldn't look right. So to show what that kind of looks like, I can remove this input variable. And now watch what happens when I press Control. The ball isn't starting out at a position that is anywhere near the player. And the second condition here is as long as the ball itself is above a specific height, you want it to continue traveling in an arc. So in the situation where the function here would finish, but the ball would still be maybe partway through its arc, it will continue to travel until it hits the ground. But this first condition is necessary because the other condition might be true when you first start something. So if you start a ball at about 0 or a little bit above 0, you would want it to be able to be launched instead of immediately exiting. So, what else is happening here? The rest of this program has to do with kind of moving the model around and setting things up to where it can be in a place that the ball is launched into the hoop, and it's something that's detected by the program. But I think the most important part of this is understanding the relative vector and the mechanic of something that can be called over time, which is this projectile function. Otherwise, this program is just loading models and setting positions. I also have a section of code that sets up a collision event. So if you want to look at that, the important part of that is the collision handler event registers patterns that collisions can generate, and whenever something wants to deal with a collision, it can do what's called accepting that collision. So the code that does that is this line here. Whenever something in Panda3D has the ability to accept a event, this can be anything. It could be the name of whatever you want. But in the case of collisions here, I've named it into sphere 1. into being part of the string that's generated when this specific collision pair that I've set up is generated, and sphere 1 being the name of the collision sphere that's being collided with. So this deals with a specific collision. And when this is detected, this specific function called collide is called. And to pass arguments to it, you can use this section of code here, which is extra args equals a list, and then whatever you want to pass to it. For me, I keep score in this program whenever the ball collides with the hoop by incrementing the text that I set up in the beginning of the program by 1. So this code is just a collision entry, and whenever this collision entry is detected, you add 1 to the score. And then here's the other part of the collision detection. Collision detection events have a special syntax for recognizing an object that's being collided with and the object that is colliding with something else. So Panda3D has a manual page dedicated to this, but in this example, the %in is the special string that is replaced with sphere 1 in my program. So you can see I named this collision node sphere 1. So whenever this collision event is detected, if the in node, or if the node that's being collided into is named this, then the name of this event will be into sphere 1. And then I kind of designed the rest of the code around that. Yeah. Also, when I was loading the models I used for this program, you might encounter an error when you first run it for some error that has to do with NURBS curves. But running it again should solve the problem. I'm not sure what it is. But other than that, I hope you found this video a little useful, or at least you found the code useful to experiment with. And thank you for watching. I will see you next time.